Okay, so hello everyone. My name is Eva, and on behalf of GenScript, I will be interviewing today Team iGEM Aachen. Welcome, Leon and Jan. Could you please shortly introduce yourself?
Yeah, thank you, Eva. Nice to be here. My name is Jan. I'm studying process engineering at RWTH Aachen, and I'm the team lead for this year's iGEM Aachen team.
Nice
Yeah,
to
I'm Leon, and I study biotechnology. I'm also in the iGEM Aachen team, of course, and I'm in the department of fundraising and also in the lab work and in our hardware project as well.
Okay, great. Nice to meet you all. We are really excited about your project and to hear a little bit more about it. So maybe let's try from tell me about your project, what it's about, and why do you think it is important?
Of course. Our project this year is called Rare Cycle. And this year we tackle e-waste recycling. So e-waste recycling, of course, is a hugely important global issue. Only 18% of e-waste is recycled globally, and there's definitely so much to do in this field. And especially valuable resources like rare earth elements, they are completely discarded right now. We completely lose them right now in our current recycling processes. And these are, of course, really critical for future technologies, for wind power plants, for semiconductors in general, for a sustainable future. So our project is to develop a new type of biomaterial filter made of fungal mycelium that can really specifically filter out these rare earth elements from a recycling solution of e-waste. So we want to express special peptides on this fungal surface that captures the rare earth ions from a solution of e-waste.
Okay, great. That sounds very interesting. And as I read something about your project, I know that also the e-waste, it's a problem that's constantly growing, of course, so it's very important to address this issue. Could you tell us a little bit more about your methodology? Maybe you use some unique applications that can help your project to stand out.
Yeah. So our main focus and what makes our project stand out is that we really want to bring our biotech solution into the daily lives of communities everywhere. So this is a huge problem, e-waste recycling, but it's also both a local and a global problem. So through easily accessible hardware, we're building a box where you can easily grow our fungus and also apply the extraction techniques directly in a box. We hope to make biotechnology accessible to everyone on Earth. So every community can replicate our solution and can use the power of biotechnology to make an impact locally and therefore also globally. So really easily accessible hardware and using biotechnology in daily lives is our focus.
Okay. Can you go maybe deeper into the methodology? How do you see people using it and using this I don't know, device or fungus? How do you see it?
So currently you can imagine it's a box made of wood we built on a recycled material. So basically everyone with minimal hardware skills can rebuild it. And it offers space and sensors and optimized environment to grow a fungus that can serve as a filter for e-waste solutions. So we're also in contact with many communities and NGOs worldwide and are trying to find a concept in which they can apply our biotechnology in their communities. So you can maybe an analogy would be plastic upcycling facilities that are already happening in communities, and we would provide a biotech solution to make e-waste upcycling possible in communities using recycled material, really easily accessible. And soon on our wiki, you can see many pictures of our box and how it works and how people can replicate it.
Okay, great. That sounds really good. Yes, because from my observation, I can see that, for example, with a lot of e-scooters, they're present basically, at least in Netherlands, on every corner. And I think not a lot of people is aware of what is happening with those batteries, for example, after we use those scooters, right? So do you do any human practices to raise the awareness of community?
Yeah, so actually the e-scooter example was our starting point among others. So when we were searching for a topic we could tackle in iGEM, we looked at our room around us and the street below the building, and we saw so many electrical devices and we didn't really know what to do with them. So we knew, yeah, okay, you have some places where you can bring them and they are recycled, but does it really work? What's happening? So the general population is really unengaged with this topic, and we want to provide informational material. We also go to schools, talk to school children. As I said before, we cooperate with NGOs to illuminate this topic, and we want to show people how biotech can make an impact on these daily problems. And of course, our human practices department has a really big role. We are active on our campus, for example, talking to students, but also going into schools. We try to really engage with the whole community and whole society and different age groups and engage them on the topic of e-waste recycling.
That's great. I really like the idea of visiting schools and educating already kids. What's the reaction of those kids? Do they even have any like eco-green ideas in their mind? Do they know how to approach this? Or it's totally new topic for them?
Jan, you were in the school visit?
No, actually,
Oh no, you
I
hadn't.
weren't,
Okay,
but
so okay, so we can explicitly talk about how these school children react, but maybe more general approach. Um, it's really interesting to see how little people actually know how e-waste recycling is done, and also how many valuable resources we just waste. So, for example, we did a little quiz on campus a few weeks ago, and these were not school children, but students. Oh, there were actually school children among them. So there were school children and students, and many of them didn't even know where rare earth elements are needed, for example, in magnets, in energy production, in daily life, and that they are just throwing it away without using it anymore. So there are many problems in e-waste recycling that can be fixed with organizational issues, like making people aware, and we want to really combine organizational solutions and technological solutions.
Yeah, that sounds really good. Yeah, thank you. Last but not least, of course, I've been seeing on your Instagram account actually that your project also is committed to making positive impact on the United Nations Sustainable Development Goals. So can you talk a little bit more about this? Maybe mention briefly some of these goals that you picked and why did you pick it?
So we really, as we developed our project, we really found many connection points to these goals, and we think that in many of these goals, e-waste recycling, innovative e-waste recycling, can really make a difference. So one of the most central goals we have for our project is to make consumers aware and turn them into prosumers. So making so this is the goal: responsible consumers. We want to turn people into prosumers, so they produce and consume at the same time and are really aware of what they're doing. And through our technology, we want to enable people coming together in their cities, coming together in their communities, and deal with their own waste. So the industrialized world right now exports huge amounts of e-waste into the global south and causes immense problems there. But we can deal with this waste on our own and also enable communities abroad to deal with their waste on their own. So this is a goal: responsible consumer responsible production that is central to our topic.
Yeah. Okay, great. Thank you. Do you have anything more to add? If you want to maybe let us, our audience, know about something specific from your project.
Well, yeah, Leon, please.
yeah, I mean, would be nice to add actually would be that you know, our hardware project. So Jan already talked about how it's probably going to look like, or how it's already looking. But the really good part, at least from my point of view as a biotechnologist, is that the fungi we are planning to grow in the reactor is actually pretty easy to grow for other people as well. So we are still going to sort out the best candidate, but in the best case scenario, this fungi would be really easily to grow for basically everybody. So not only would our wooden bioreactor be easy to build, but also the biotechnological organism as well would also be very easy to cultivate. So I guess this is really a pretty unique thing about our project, because this makes even the biotechnological part, which would usually, you know, be more accessible to people with access to laboratories, easily accessible for basically everybody.
So I could grow it inside my house and then be more eco, I guess.
Yeah, well, of course, we still have to take into account the European regulations and stuff, but in theory, yes.
In ideal world.
Yeah.
In an ideal world, yes, everyone could do it in their backyards, but considering safety protocols, this will be probably something you would do in a community laboratory and community workshop space in your city. Also very accessible. So maybe in your neighborhood and not in your garden.
Yes, that's great. That sounds good. Thank you very much for sharing your insights about your project. And I wish you all the best during the iGEM competition and also during our GenScript giveaway. Thank you for your time, and it was really a pleasure to talk with you guys.
Yes, thank you
Thank
very
you.
much.